Holy smokes, look at the picture on this one. We're answering like a few questions on this, so let's just jump right into it. We have ourselves a graph. It's probably a rational function because we have all these curves and explosions. We have asymptotes, we have leveling out. Definitely a rational function. All right, so state the domain of f of x, use interval notation. The domain is basically where the x is being represented. Now, we have two places where x is not represented. Anytime we see an explosion where it goes down and then reappears, there's an asymptote there. And it appears that one of my asymptotes is at -2, and the other asymptote appears to be at +2. So that means my domain is going to be everything but -2 and +2. How do I write that out? Well, in interval notation, we go left to right and we say -infinity with parentheses, because we never include negative infinity, to -2, but don't include -2, so parentheses again, union. And then we pick up at -2 without including it. We go all the way over to regular 2, don't include it, union, and then regular 2 on forever. That's my domain. Find f of 9. That means when the x value is 9, what's my regular y value going to be? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it's right there. So I'm going to go with 1. Find the y-intercept. That's where my line right here crosses the y-axis, and it happens right there, so we'll call you -2. Find the x-intercept. That's where my line crosses the x-axis, so right there at -1. And that's it. All right, so we've answered 4 of them. Let's clean this up a little bit, get a new color, and keep this train rolling. State the interval or intervals where f of x is increasing. All right, well, from the left to the right, decreasing, 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 disappears, way up here, decreasing, 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 disappears, way up here, decreasing, decreasing, decreasing. So where is it increasing? Never. State where the interval is decreasing. Well, it's always decreasing. We just figured that out. So it's basically the same as that. It's decreasing to -2, and then from -2 to 2, and then from 2 and on forever. So the same as a -infinity to -2, union, -2 to 2, union, 2 to infinity, and beyond. Well, not and beyond. There's no such thing. Find the limit, if you can read that. I can barely read it. As x approaches -infinity, that's what I'm hoping it says, of f of x. That means as you move to the left, where is my line going? Well, my line appears to be leveling off at the x-axis, which means it's never going to hit it, but it's approaching 0. And even if I couldn't read this, I mean, that's going to be the same thing, which I'm sure we'll get to. G says that we will, so I'm jumping the gun. As x decreases without bound, the f of x does what? Well, that's basically what I answered for k. K just says as x gets smaller, so as x decreases without bound is asking the same question. So what we'll do is we'll use words, and we'll say it approaches. That's not how you spell approaches. It approaches 0, or the x-axis. Find the horizontal asymptote. The horizontal asymptote, if not given a function, is where everything seems to level off. Well, on the left, it levels off at 0. On the right, it also levels off at 0. So the horizontal asymptote will be the x-axis. We write out the x-axis as y equals 0. Remember, a horizontal line is y equals a number, and in this case, it's going to be y equals 0. State the intervals where f of x is less than 0. In other words, where my line or my graph is underneath the x-axis. Well, it's underneath the x-axis all the time so far, and then it stops at -2. So right now, from -infinity to -2 is where it's underneath the x-axis. And then it reappears above the x-axis and hits the x-axis at -1. So we're not going to include -1 because we're not allowed to include 0. But after -1 and going on to regular 2 is where it's going to stay under the x-axis. Then it reappears above the x-axis and remains above the x-axis. So these are the only two intervals where it's less than 0. Switch colors again. Find the limit as x approaches regular infinity, if I can read that correctly. As we saw from before, it levels out right at 0, so that's going to be 0. As x increases without bound, the f of x, basically the same thing that L is asking from k, h is asking from g, it's going to approach 0. Look at me spelling it right. Estimate the points of inflection, which means where we have a change in concavity. Well, the only place I see a change in concavity is going to be like right around here, maybe? Maybe right around there? So we'll estimate 0, negative, what was that, negative 2? We'll estimate it. You are going to remain concave down because you are never going to flip back down or anything like that. And you're going to remain concave up because you're never going to show back up again. So that's the only inflection point. Find the average rate of change over the interval negative 1 to 0. So that's negative 1. That's 0. The average rate of change is a slope where we go down 1, 2 over 1. So we'll say negative 2 over 1, which is negative 2. Holy Christmas, that's a problem. But we did it.